to my speech about Go language, and somebody told me that if there's a question mark at the end of title, it means that the answer is no. So, thank you. No, actually, the Go language isn't that bad, especially if you compare it with, for example, Java or C.
Louder and use the microphone.
Okay. You know, today there's a lot of programming languages, and you can learn them, and you can start to use them, especially if you work in a microservices world. You can choose any language for any microservice. So the question is, should we learn them all? Probably not. We don't have enough time for it, and let's be honest, most modern programming languages are not worth to learn it at all. But what about Go language? I think that it isn't that bad, and which is interesting. People who use Python usually love Go language. I don't know why. Probably it's a clean syntax or something similar. But usually Pythonists loves Go language. If you use, let's say, JavaScript, you are doomed anyway. So you are not proper persons for using Go. But let's try it. This is the official mascot of Golang, the so-called Gophers. And introduction. The Go language was introduced 10 years ago by Google, which is interesting because you know Google is very good in searching services, and they choose the name Go for a new programming language. You know that the Go has many meetings. It's okay. It's yes.
Is the microphone working?
I don't know. Is it better?
It's not good. It is working, but you are too far away.
Okay, so
Try to move it or like take it to your hand.
yeah. Okay. Sorry, I'm not used to use this thing. Okay, so it was launched 10 years ago by Google, and everybody seems to like Google, even Red Hat and IBM, because we use their services. The main author is Rob Pike and Ken Thompson, and you probably know these guys. And well, I would say that it's typical that this programming language was created by the real senior developers, senior in meaning of age and the knowledge. And it should be more readable replacement for C, C++ and Java, especially for C++. Because almost everything is more readable than C++.
Very low bar.
Yeah.
Well, there is still Perl, right?
Yeah, but nobody uses Perl anymore. I hope at least. So the Go programming language is compiled. It's truly compiled language. It is compiled into machine code, so there's no bytecode or something similar. It's statically typed. So if you like static type languages and strong type languages, you will probably like Go as well. It uses a garbage collector, so you don't need to worry about the memory usually. The nicest thing about Go is that it has a built-in concurrency support. You will see it supports goroutines and so-called channels to cooperate between green threads. It has a strict formatting rules, so there's no argues about should we use tabs or should we use spaces or something like this. There's one rule and everybody uses it. And this language is used on server side, basically on server side, and in cloud computing as well. You probably know Kubernetes, Docker, OpenShift, and such things, and most of it is written in Go. It's available for all interesting systems. So it means Linux and I don't know how it's named. This thing with Apple, and it can be used on Windows as well. And it works on most architectures. Right now, these are the Go use 32 and 64 CPUs as target. So there's no support for microcontrollers yet. Yeah, so this is different from C, for example, because C is used from 8-bit microcontrollers up to supercomputers. And it uses the custom backend compiler, so it's not based on LLVM, for example. Yeah, so this is quite special, and this is a bit problematic approach, because the Go compiler is not as good as LLVM, for example. Okay, the goals, when the Go was created, there were some goals, and most of them were met. The first is simplicity. There's almost no magic in the programming language compared to Perl, for example. The bar is still low, I think. The next thing, performance. It's not bad in Go, but if you compare the benchmark results from Go with results from C is still better. But if you compare Go with Java, it's comparable, so it's pretty good. And the applications written in Go should be safer compared to C++, because we all love buffer overflows and similar things. So it's almost impossible to do it in Go. Now it's used for microservices. This is the next big thing in IT, I think. And another interesting thing, Go is easy to install. Go applications, or applications that are written in Go are easy to install because Go compiler uses static linking, and everything is linked into one binary file that can be distributed. That's all. You don't need any shared libraries or any other files to run the application. Yeah, the result is quite big. If you compile the Hello World example, you will get a binary file which is larger than 1 megabyte, and because there's a runtime library inside for GC and for other things, and for example, the OC client, which is a command line application for OpenShift, is larger than, I don't know, 100 megabytes?
300 or 500.
3, yeah, probably. Yeah, so it's just one binary with everything included. So every package you import into your application is linked into one binary file. So this might be huge, but if you compare it for, I don't know, for C, and if you count how many libraries, dynamic libraries are used by C programs, it might be comparable. I don't know. And if you compare it with Java runtime environment, it's even bigger. And the compiler is pretty fast. It's really fast, which is good. I sometimes use Go on the ASUS EEE, if you know the old netbook, and it worked good. Yeah, the Go compiler is pretty fast, even on this machine that has 1 gigabyte of memory and the hard drive. Not a problem. So there's an attention slide. There's one problem with Go is that it's a blend. It's just some mix of modern approaches like concurrency combined with quite old ideas. Somebody wrote that it seems that the authors of Go were frozen for 20 years and they were awakened yesterday and they designed the new language. Sometimes it looks like it, because in Go you have quite problematic error handling. You need to handle all errors explicitly using the if conditions and such things. There's no generics in the language. There's no templates, no class-based object-oriented programming, which is good, I think. There's no try-catch finally blocks. And on the other hand, Go has GoTo keyword. So if you like GoTo and Basic and these languages, you will like Go as well, I think. And there's a nil identifier. I will talk about it later. It's quite problematic because it's polymorphic.
Question?
Yeah.
Are all these concerns valid also for Go version 2?
We don't know because the Go version 2 is not finished. So yeah, you are right that there's proposals to have a generics, to have something like try catch finally, but I think that it's not finalized. There's some process that needs to be met. What I think that in Go 2.0 we will have some minor improvements, like it will be possible to write integers in binary format using 0b something. It will be possible to use spaces in integers to split thousands from other things. But this is minor things, so we don't know. So when we compare Go and C or C++, the Go has a much stronger type system. I would say it's really good. On the other hand, there's no macros support. Even the simple substitution macros used in C can be used in Go. There's no header files or anything like this. We have a quite good package system using imports and using packages. All memory operations are safer because the memory can be allocated automatically for most data types, and there's a GC, garbage collector. There's a standardized framework for unit tests. And the language itself is derived from C. I mean that the keywords are almost the same, operators are almost the same, but the rules are a bit stricter in Go. For example, plus and minus operators can be used in postfix notations only, and only in statements, not in what's the name?
Equations.
Yeah, equations or something like this. Pointers arithmetic is very strict in Go. You can't do much with pointers, just to point to some content of memory. There's no templates, as I said, no exception handling, control structures, and no generic data types yet. So why to use Go if it lacks many cool things? The first thing, we know that we have a problem with performance of new processors. I don't know if it's, is it readable, right? Okay. There's a problem that the performance of one core is almost the same for the last 5 or 6 years. Yeah, the performance of one core. So where we go to the better performance of new processors? By using multiple cores. So to be able to use the new CPUs properly and efficiently, you need to be able to use more number of cores. So some form of concurrency is needed, and you can see the number of cores is increasing. The same is true for the floating point performance. There's a point where the floating points performance starts to accelerate slower or decelerate. Yeah. So these are real data, and everybody knows about it. For example, the older laptops is still very performant compared to current one. So how to support concurrency? In classic languages like C or Java, you have threads. Yeah, you can create threads. You can share the memory with threads because you need to cooperate. The threads need to cooperate. In Go, it's different because the goal is to not communicate by sharing memory, by sharing some blocks on memory. It's better to share memory by communicating. It's Rob's like goal, and so Go use so-called goroutines. We can look at goroutines as a green thread. Yes, so it's very lightweight. The green thread don't consume much memory. By the way, who of you use Java, for example? Okay. How many threads are you able to create and run in parallel? On a real machine, it's lower. Yeah, 3,000. Yeah, probably yes. In case of goroutines, it's larger because the goroutine itself needs just a small amount of memory. It just needs one stack frame. Yeah, let's say it's not much. So goroutines are very cheap to create. Yeah.
Have you tried to compare it, for example, with goroutines in Kotlin?
To be honest, I don't know if goroutines in Kotlin are really parallel. I don't know.
In Kotlin you have the coroutines are just objects that are dispatched on threads, so it should be the same as goroutines in Go.
Mm-hmm. So it may be comparable then. Yeah. The key thing is that the goroutine is not tied to operating system thread. It's something more finer. And it's possible even on a small machine to have, let's say, 1 million of goroutines. Not a problem, not a big problem. Yeah. So goroutines are used to support concurrency, and how the goroutines can communicate each other. In Go, there's a data type named channel, and channels are used to communicate between goroutines. In fact, you can create an array, for example, and pass the pointer to the array to goroutine. It's possible. It's still possible, but it's not a good approach. Yeah, because you won't have a control about what will happen. So channels are preferred way, and they works like people, like queue. So let's look like the Go program looks like. This is the hello world example. Nothing special. There's one function, one import statement, and we call the function print line. There's no classes, no objects, nothing like this. Even semicolons are not here, and I used to like languages without semicolons because I started programming in BASIC. So let's look at Go fundamentals. There are just 25 keywords, including the goto, but other keywords, not all, but most keywords are the same as in C or Java, for example. Okay, data types, they are similar to C. If you declare some variable or parameter to function, you need to use postfix notation, so it's different from C. In C you use the mixed notation. Something is written before the variable name and something after the variable name, and it's quite complicated. In Go, it's easier. The Go uses type inference and default types. It means that you can declare a variable without defining its type. You just declare a variable and assign some value, and the type is inferenced automatically. And for each type, there's a pre-declared zero value. This is because Go doesn't contain something like constructor. Nothing like this is used in Go, so we need to have zero value for all data types, including structures and so on. So primitive data types. This is easy. The integer types are specified precisely as in Java. So it's different from C, when you don't know what int means, for example. And there are complex data types, complex 62 and so on. You can use it for some computation for complex numbers. And there are 5 so-called composite data types: strings, which are immutable, support Unicode. The Unicode is fully supported in Go because one of Go author is also author of Unicode and UTF-8. Also, arrays are possible to create in Go. They are mutable, of course. They have constant size, as in C and Java. And if you need something like arrays which can grow, you can use so-called slices. We'll see. And something like objects are created by structures or records, and you can use maps as well. So associated arrays are supported. The other standard types are pointers, functions. Function is a proper data type in Go. Interfaces and channels are communicated between goroutines. So structures, you probably know it, how it looks like. There's a definition of structure named user. The structure has three members. You can do some initialization and print the output. You can do the initialization of a variable using the shorter format. Here you can see the special operator that creates the variable, infer the type of the variable, and assign some value to it. So it's quite similar to Python, for example. Yeah, you don't have to specify that user1 is of type user. And there's a better form of initialization of members using the tags of the members, which is better because if somebody changes the structure, if somebody adds a new member, you don't have to rewrite all the code. So arrays, this is a basic data type in Go. There's nothing special for arrays. They have some size, and it's impossible for array to grow. It's created in memory during the runtime. So this is an example where three arrays are created. You can see that you can create arrays, specify data type, and perform the initialization of items in array. If you don't do the initialization, the zero will be used by default. That's nothing special. Arrays can be copied very easily by using this statement. Unlike in C, it's not possible. So this means that a new variable is created. The type of the variable will be array of 10 integers, and the content of the array A1 is copied into A2. Nothing else.
Structured data types are also copied deeply or in the reference.
Deeply in the first level.
Well, they are deeply unless there are some pointers, right?
Yeah, pointers are copied.
As a pointer.
Okay.
Yeah.
The more interesting thing is so-called slices. Slice is implemented in memory by using three values: the pointer to some array, the capacity, and the length of the slice. So the slice itself doesn't contain any items. It just points to some array. And the good thing is that it's possible for a slice to grow, because internally the array could be rearranged, and the items are copied, and so on and so on. So this is a pretty good idea, and I think that it was taken from Rust programming language. I'm not sure, but it looks like that Rust was the first language that used slice type. Yeah, how it looks like, here we have two arrays, A1 and A2. They have some length, that's not a problem, and here we create a slice and put well, the slice will contain the content of the array A1, and if you update the array, the slice content will be updated as well, because it's the same memory. Yeah, there's nothing in slice recorded. So the operator to make a slice is similar as in Python, for example. You need to provide two indexes, and the slice will be created. You can try it. It's not a problem. Yeah. So. Each slice has some length, that's actual number of items, and the capacity, that might be larger. That's not much interesting because we don't have time. Well, in Go it's possible to use the append function. It's a built-in function that can append item or more items into the slice. Internally there's some array under the slice, and it could be rearranged, and the new slice is returned from the append function. So now we first create the slice which is empty, which means that it points to empty array, and then we append some items into the slice, and then the slice will grow. Yeah, from the programmer's point of view, the slice will grow. Here you can see that the capacity is usually doubled and the slice is full. The capacity is full, like in this step. The new array will be allocated, and the new array will have two times items than the array before. Well, the algorithm is more complicated, but from the developer's point of view, it works pretty nice. You can also use maps, like associate array. This is more complicated because you need to provide the type for keys and type for values, because maps contains key values pairs. And you need to use the built-in function make to create a structure for a map. The map can grow in memory. That's not a problem to add new items using this syntax. There's nothing like method put or something like this, you can assign new values to new keys. No problem. And we also have pointers in Go, but compared to C, the pointers are not such useful, I would say, because the pointers either contain a null value, the special null value, or they contain the address of existing element in memory. There's just two operators, the ampersand and the star, the unary operators, nothing else. There's no pointer arithmetic, for example. You can't do plus plus, minus minus, or something like this. And the Go supports automatic dereference. It means that when you have a function that accepts the pointer to something, you can call the function without using the ampersand operator, and it will work. So there's a basic usage of pointers. There's a variable named I that contains some value. You can create. Yeah.
What's actually your opinion about the ability to omit the ampersand operator and just directly use the reference? Because sometimes when reading Go code, I find it slightly confusing because just looking at the function calls, I can't say what is actually a pointer and what is a real value type.
Yeah, I usually don't care because it works. No, really, there's no situation, or I hope there's no situation when the compiler is confused. So if compiler is happy.
Yeah, essentially the only the primary reason which I found out is memory. So it never happened to me when writing a piece of Go code that I had memory issues, but I've never written a line of production grade Go code. So if I were to actually hit an issue where there are problems with memory, I can imagine that it would be kind of hard to debug. But granted, I don't know what tools and profilers are available for Go on. So
Yeah, well, profiler is part of standard tools in standard installation of Go. For debugger, you need to install Delve debugger. That's the best one. Yeah, but well, and where's the problem? If you look at this source code, is it problematic to understand? I mean, this one, because these are all operations you can do with pointers.
Yeah, I would say that the only thing where the dot operator is actually applied with the reference is only when you are talking about structures.
Yeah.
Only use defined types, because in case you have slice, you have to dereference before you will use square brackets, etc. So only in this case, and I would say that in Golang the pointer is actually a pointer, it's reference, right?
yeah, exactly.
Because it can only point to existing object or now, nothing else.
Yeah, so it's a bit safer, and well, you don't use pointer much in a real Go code. Well, this is an example how to create a pointer to structure. This is not the whole thing, but yeah, sorry, this is, but it works. No, the problem is that there's no the arrow operator like in C. In C you can use the structure, arrow, item name of item to point to something in structure. In Go it's not possible to use this operator, but it's not needed because you can just use the point, nothing else. The structure, the pointer to structure, point, dot something. And that works, that's automatic. Just forget that C++ and C is different. Functions. One of the better thing in Go, functions are a proper data type in Go. There's a support for closures, so the function can close over the variables around the function, which is which is good. In many cases you need it. The functions are variadic. You can use variable number of arguments, and also functions usually return more values than one, which is good as well, because this is one thing that's used in Go very often is to return some value, the return value, the proper return value, and then some error. So the easiest thing is to return two values, compared to C when you return either the value or, I don't know, no, -1 or something special. This is, I think, better. And the return values can be named. I think that I have some example how it works. Yeah, this is it. So the first this function get message. Nothing like this. This is function without arguments. The function returns string. This is the return type of the function, and the return statement is the same as in C. That's not a problem. We can also name the return parameter. I don't know how to name it, but the return parameter can have name, and you can assign something to the return parameter. So it's like proper variable inside the function, and you can use this approach, and it will work without problems, because compiler takes care if the string is really returned, and it works, and it needs to be used this way. I don't know. Yeah, in different statements. Yes, sometimes you need to return something special in a different statement, and you can use this approach.
What happens when if I actually were to do message string, message equal hello world, and then return hello universe?
It will work. It will return the universe. Hello universe.
Okay, so it's just like
You
if
can assign-
specify
yeah.
the value after return, it defaults to the value of the
Yeah,
output variable.
you can combine it. You can use multiple return values, like a sub function that accepts two integers and returns the same integers but in opposite order. And I would say this is quite nice. We have a strong type language with static types, with everything. The types are processed during compile, not in a runtime, but we don't have to specify anything here. We just say, I need new variable, assigned 1 to the variable, and the compiler thinks, yeah, well, it looks like integer, let's use integer. Yeah, so it's pretty nice. It's similar to Python in this way. Control structures, this will be fast. Here we have conditions. This is almost the same as in C, but you don't have to use parentheses around the condition itself. It's more readable, I would say. You can use some variables local for the blocks. This is quite cool as well. Else statement is the same, nothing problematic. So you have a switch statement, which is different, which is a bit different. In C and Java, because Java copied all the worst thing from C, we usually need to use the break statement in switch case, the construct. And if you forget to put a break into the code, something bad usually happens. In Go, it's the opposite. You don't have to use break to end the case statement, but if you need to evaluate more cases, you need to use the for true. This is keyword for true. To basically join 2 or 3 case statements. And well, the authors are right, because I did a small research. I downloaded many Go code, and I I looked for the keywords, and the for true statement is the least used keyword at all in Go. But in C you need to use break, and in Java you need to use break very often. So in overall, the code written in Go is shorter because you don't have to use the break statement. So it's you need to learn it. Yeah, that it's different. But in reality, the switch statement is more powerful in Go because the values used in a case branches don't have to be constants. You can call some function. You can use almost anything here. Any expression of the proper type. Yeah, so it's not bad.
But it can't do something like pattern matching, right?
Pattern matching?
Pattern matching. I mean, like.
No, the proper pattern matching isn't implemented in Go. Yeah.
So you can also use casting.
Yeah. This is another example of the conditions that really are not constants, like in C. Well, in C it makes sense. In Java, I still don't understand why they use the switch statement in the same way as in C, because it doesn't make sense. I mean, really. So loops. This is easy. There's just one keyword for making loop, and it's a for keyword. And you can create many type of loops using the for keyword, the classic C-like loop with some counter, the while loop, and endless loop, basically. So you don't have to use something like while true or while one, something like this. Just use for. The other thing, I said that Go doesn't have anything like try catch finally, such blocks, but usually we need to make sure that if the function ends for any reasons, something needs to be done, some cleaning. For example, we need to close file, we need to clean up memory or something like this. And for these reasons, Go use the first statement. It's used to remember some commands that will be called in all cases before the function ends. And the parameters that can be used in the first statement are evaluated in a runtime. We will see. This is the simplest example. We have a function main, and we say, hey, when the function main, well, before we exit from function main, let's call the onFinish function at the end. And it works. Yeah. This is the line that's called. You can also create a anonymous function in the first statement, because as I said, functions are proper data types. So you don't have to specify the functions and assign a name to the function. You can use something like this. So the keyword function is something like lambda. It's the same. This is not interesting. This is better example. Here we create the 10 different statements, and they are evaluated using the stack behavior, last in, first out, which is usually okay. Yeah, so the first statement is called, the last one is called the first, the second one is called then, and so on. This is okay, because if you write some code, like open one file, do something with the file, open second file, do something, you need the file to be closed in opposite order. Well, next thing, error handling. there's error as a built-in type, and I will show you later how it works. Well, there's a goto keyword. I don't have any example how to use goto keyword in Go. It's usually not used much. It's used like, well, I saw it actually. I saw it, but it was a very low-level code in a Go itself, in a Go compiler. So sometimes you can see that Goto is used, but not much. Definitely not in like in this program. Who knows what this program computes? It's easy. It's basic, you know.
The GCD, isn't it?
Yes, yeah. You want something. I don't know. Operators, we have many operators in Go. Most of them are almost the same as in C and Java. Yeah, so this is first thing. There are some interesting or some operators that differs from other programming languages. For example, if you need to perform bit by bit negation in C, you use tilde, or how it's named. In Go, you need to use this operator. I don't know why they changed it. Well, then we have the classical bit operators and XOR, that's not a problem. And we have so-called mask operator, which is not bad. Yeah, if you need to mask some bytes using the AND not operator, you can use it. The other two operators that are special for Go is operator for a new variable declaration and initialization, and the arrow, but pointing to left, not to the right, is used for two-channel operations to send something, some message to channel, and to receive something from channel.
So the operator for unary negation is the same as the operator for XOR.
Yeah, but it's a unary operator. If you use
Yeah.
I don't know why they don't like to do that. You know? Yeah. Well, plus, minus are not proper operators because they must be used as statements. So nothing else. I is okay. Something I star 10 is not okay. Even in C, it's quite complicated to comprehend these operators. And these operators in Go are written in postfix variant only. It means that you need to write the name of variable first and then the operator, not vice versa. That's it. Well, the programs in Go are split into packages. And packages can be imported. There are some standard packages. The good thing is that there are ways how to install the packages into the directory structure. So usually you will have, at least in the standard Go 1.x, you will have a standard directory structure for all programs. So there's no magic like in C programs using makefile and in Java using payload. Nothing like this. There's just one way. Still, there's one way how to where to put the packages and how to import them.
Is there though? I mean, when it comes to stuff like vendoring and stuff, like essentially depending on the build tool for Go you choose, the significantly changes the location of your Go path.
Yeah.
Totally outside what is actually Go path on your system, and the entire concept of Go path where you need to put your own program with the mess which are all the libraries used by all your programs on your machine.
Yeah, but Go path will be obsoleted.
Will be.
Will be, yeah. Actually,
This was actually the thing which made Golang almost off-putting for me, and which stopped me for learning it any further, that it seemed like such a mess. I mean, like, any time I wanted to use it, it was a complete mess, like out of the dependencies and where I should put my programs. And
It's easy, if you follow the rules, it's easy.
Well,
If you want to bend the rules.
a year and a half ago, it was basically Wild West.
It was, yeah.
There were like 3 different package managers or whatever build systems, and none of them like work properly. Like, each of them has its caveats. So.
It is. And do you know how Google at least used Go?
No.
I don't know how they use Go right now, but they use Go in a way that everything that's needed to build their services is stored in one repository. Everything. Even modules, even subservices was stored in one repository, and there was just one API that there wasn't support for basically for changing the API without breaking any the other programs.
Was it even possible to do like a versioning? Could you have like 2 programs which depend on the same library in different versions on the same file system with a single Go path?
No, if you really want to use the single Go path.
In that sense, it's similar to Python, right?
Yes, the transitive dependencies are.
Technically yes, but it was solved since by using equivalence, right?
Yes, exactly. But that's what's the difference between a virtual and a Go path?
Is there something similar for Go now?
I don't know.
No, the one problem is that everything, at the end, everything will be included in one binary. So if you have package X and function Y, there will be one function X point Y in the binary, in the resulting binary. So there's no way how to use 2 versions. But the approach that the Go authors wants to use is that the API can't change, which makes sense. Because if you change the API, you can rename the package. I don't agree with
Yeah,
this.
it leads to this kind of thinking, like I want to create new API, so I will basically create a new sub-package, like it's in case of YAML. Like you have YAML /v1, there is complete implementation, and there is in the same repository YAML /v2, and there is basically copied implementation with some enhancements, right?
Yeah.
And you can't break the API yet.
So this is a bit problematic. On the other hand, I think that the Go shouldn't be used for such a big applications that has many transitive dependencies.
Another thing is that Go essentially works is you to have a single point of failure in your dependencies in form of the repository where you can publish the code of the library, because you need to essentially you need to release into single Git repository. It's not like in the case of Maven, for example, where I can define 15 Maven repositories, and as long as one of the mirrors works, the dependency gets downloaded. Like if I host my repository in GitHub and unicorns start showing off, I cannot build.
Yeah, you still can.
Correction language.
That's one problem. The second problem is that it's tied to GitHub usually.
You can actually you can use whichever Git repository you want, as long as you have the URL for it.
Yep.
Or domain name.
No, I mean transitive dependencies. You can say that you have package for YAML, for example, and you need to have the same package from another.
Yes, at the end you should end up in the state where, unless GitHub works, you won't build the application.
Yeah. Well, personally, I think that if GitHub stops working, I think that the half Red Hat or something, it will stop working.
Not
OpenShift,
really,
the whole OpenShift.
Yeah, usually like in other languages, like in Java, like if it's published, in JavaScript it's published to the ready repositories, it's already there, so it's kind of dependent on the source code.
I agree. Yeah. I think that's a problem that needs to be fixed. And on the other hand, I think that Google itself don't have this problem. Because it seems to work for them well, for their ecosystem, let's say. But we who wants to go for bigger programs, it might be problematic, definitely. Okay.
You mentioned bigger programs. What's the usual sign?
Yeah,
Putting OC aside.
yeah, Kubernetes sounds like a pretty big project.
To be honest, I don't know how Kubernetes are.
I would classify it as a large program.
Yeah, but I don't know how many lines is written in Kubernetes and how many lines are imported from other packages.
Yeah, but I would say that at least in case of Docker, I believe that there are not many dependencies, right? Basically, we
Yeah,
from scratch. Because in Go there is one big advantage, you have access to the low-level APIs of operating system. So you don't need to do much in this regard.
Actually, they separated the Docker project and Kubernetes into so many other projects, and they basically vendor it in, so they include it again in the existing repositories. So,
You mean that the whole repository is cloned in some state, in some version?
like Docker depends on, like, I don't know, run C, and run C is separate repository, but the Docker will include the code in /vendor something again. That has certain advantages and disadvantages, and they are working on it.
Yeah. Well, I'm not sure how they update the vendor part, but probably it's possible.
It's a mess, but yeah, it's improving.
Okay.
For 2 years.
Okay, next thing, threads and goroutines. Usually threads needs to share some memory. Go uses goroutines. And yeah, there's a simple Go keyword. The Go is keyword used to spawn a new goroutine. Yeah, it looks like this. We create three goroutines. Basically, the first goroutine is the main one. The second calls the function f, and the third one, the function f as well. So it works. Well, there's nothing special here. Yeah, deadlocks. I like this image because it's, well, actually it's not taken in Brno. Yet, but we are very close to.
Because in Brno, the deadlocks are more topologically interesting.
Yeah, but here you can see at least 2 or 3 lucky drivers. But in Brno there's no. Yeah. So deadlocks. These are checked at runtime. Yeah. Usually, if you use something like this, you create a channel. You send something into channel and read from it. It's wrong because if you send something into channel, it's a blocking operation because the channel has 0 capacity. This channel has 0 capacity, so it starts waiting for another goroutine to read from the channel, which can happen. So the deadlock is checked at runtime. The program stops working, and you can see which goroutines are there, and that all stops.
What does it mean that the deadlock is checked at runtime?
It means that you.
I mean, it gets deadlocked.
No, it means that the application stops working immediately,
Okay, so if I recognize it, that it's
Yeah.
not state and not try.
Yes, without needing to have
Yeah, so
in Java something like watchdogs and something.
It will crash instead of freezing.
Yes, and it crashes or exits immediately, almost immediately. It's
So what we are detecting is that no routine can make progress.
yes.
So if I have
Well, in most cases, yeah, I think that it's possible to write some special code that where the deadlocks won't be detected, but in the case you use the channels to cooperate between goroutines, it will work.
so if I have 3 routines, 2 are deadlocked and the third one is running and it's printing.
That's okay.
A letter array.
It's okay because if one goroutine works, runs, it means that the program, the runtime don't know what the goroutine will do in the future, because in future the one goroutine can unlock the other things. Yeah. So at least one goroutine needs to run. Yeah, channels can be used. Yeah.
Can you see how many routines are blocked and how many are running?
Oh yeah, and there's a profiler that has a graphical output, HTML output with some graphs, and you can see how much the goroutines are used and where they stop and these things. Yeah, here these are channels used as FIFOs or queues. This is one channel with capacity-free items. In this case, the send operator can send at least 3 items into the channel without blocking. Yeah, so it works. Channels can be used to control the goroutines using the read-write operations. By the way, this image, this snapshot is true. This is from America.
It's not from Berlin.
I think that we need to use something like this. But this is interesting to have such sign in reality. I think that this is the approach used in IT as well, because you have not working lights and you patch it by using. Yeah, yeah. If you work with channels, you can use the select statement. Here we have some worker that puts something into channel, the one into channel, and the select statement basically waits for at least one event, let's say one event from any channel, channel 1, channel 2, or there's some timeout specified, which is nice. Which is nice. It's very hard to write it other way without the select case control structure.
Will you close or destroy the workers which are blocked and making some error? On the next slide,
Yeah.
let's say first channel responds, and second channel would block for next 2 hours until it gets data.
Yeah, in this case it's not a problem because the select is not written in a loop. So the select selects the first message, and the goroutine will continue working.
Yeah.
If you need to read from the channels in a loop, you need to.
It's really like select and see.
Yeah.
So you have a set of places where event can happen, and you are waiting for any one of them to wake up.
For just the first event,
Yeah.
not. So for message from channel 1, or for message from channel 2, or for the timeout 2 seconds.
This is timeout for reading. Is there an option to have timeout for writing? Like I have limited capacity on a channel and too many producers in the mix. And I want to produce that's blocking.
Yeah.
And if that doesn't work in 2 seconds, I want to continue with something else. Is there an option to do?
Yeah, you can just put the select into loop. I think that this.
understand the...
I mean, producer case, when I send.
Yeah, the case can be used on producer as well. Yeah, you can use the operator on the right one. Error handling, there's no try catch finally. Well, everybody likes try catch finally, like this guy. And you need to use explicit check for every errors. There's an example, a typical example. There's a function that tries to copy the file, not the file like CP, but content of first the file to second file. So we try to open the source file. If the error occurred, we need to do something with the error. So we need to explicitly check for the error. And there's, of course, the fair statement that tries to close the file and the function exit. So this is the typical thing you will see in many Go programs on many places. Explicit check for errors. Yeah, the error is either nil or some error. Yeah, so it should work. Interfaces. Yeah, I like this image because my team uses such interfaces in many places. But it works, yeah. Yeah, in interfaces you have defined set of methods. Nothing else, just headers for methods. So the method name, parameters, return values, and types. And what's interesting is that any user type that implements these methods also implements the interface. There's no keyword like implements in Go compared to Java. In Java, you need to explicitly say yes, this class implements this interface.
It's essentially a type class.
What?
It's essentially a type class.
Yeah, it's a type class. Yeah. Which is good. I like this approach. Yeah, they use the word satisfying the interface, not implementing the interface. Tools like this. Well, we can embed the interfaces without problems, so that doesn't take worse. And how many times? 5 minutes.
Yeah, what are we?
10 slides. Okay. This is a program that tries to use circular embedding because interface I1 embeds interface 2 and so on in circular. This is detected by compiler, of course. Yeah, this is just an example how to declare the real interface. There's interface named OpenShape that has one method that computes a length of something and returns float 64. There's another interface that has two other methods. Yeah, to implement the methods, you need to just use this syntax. Nothing else is needed. This is the implementation or satisfying the method of interface. The line, the first, this is not parameter. This is receiver is the type of usually user data type that implements the interface. And in Go, it's possible to have a nil value that's not equal to another nil value. This is special case, like in this program, I hope. Yeah. That creates a variable of type interface. This is empty interface. This is a 0 value for interface type, which is nil. Here we create another variable of type t, which is pointer to int, and we assign nil to the pointer, which is possible. Why not? But if we compare these two nils, we go to false.
This slide is actually shameless promotion for Pavel's latest article on it.
yeah, today.
So does that mean like if I created two variables of type t, would those nils also compare to false or not?
No,
Those would be.
So these are like typed nils.
Yeah, the problem is, the actual problem is that for interface, the interface has two values, two types. The static type, this is the type of interface, and the dynamic type, this is the type of the variable or variable value assign it to the variable. So there are two types internally. This can be seen on this program that prints the type, the actual type of the value and the value itself. So you can see that the value is nil in all three cases, but the type is different. And this is problematic. Most people who try to learn Go we will see this problem because
People are getting hungry.
yeah. Oh, this will be yeah. Almost the last slide. Standard libraries in Go. If you install Go, the installation itself is 300 megabytes, I think, and you will get quite big standard library with networking functions, with crypto and security functions, everything that well, basically Google needs to implement their services. Yeah. Image encoding, recording, raster image encoding, recording, and one of the best packages is the HTTP server, which is based on goroutines. You can create the HTTP server that provides dynamic content in 3 lines of code, which is nice, and it's scalable and it works perfect. I'm sorry?
And compiled into non-binary.
Yeah. By the way, this presentation is provided by Go Presenter, which is a Go program that's a HTTP server. Go formatter is a tool that formats the code. There's just one set of rules. You can't say how to format the code. There's just one set of rules. So nobody likes the style, but everybody likes that the Go formatter exists, and yeah, that's okay. Go test is a standard unit test framework. You can see this is pretty easy to use.
The error F is not standard assert, I think it's
No, there's no assert.
very ugly.
That's explicit, I would say. Yeah, I personally don't agree that the assert is not in Go. I prefer to have assert in Go, but I mean this is standard library used in Go. Yeah. So is it worth spend time learning Go? Yeah, if you do network services, yes. Microservices, of course. Scalable systems, yeah. You need pretty fast compilation and the simplest deployment. I think Go is okay. If you like class-based or object-oriented programming, Go is not for you. If you like Baroque languages, Perl, C++, no, then actually. If you like inconsistent languages, JavaScript, for example, well, use JavaScript. If you like homoiconic languages, I like, but Go is not homoiconic. Lisp is or Clojure is.
So what is homoiconic language?
Homoiconic means that the program itself is represented by the data type in the language. So you can create a true macros, for example. If you know Lisp is homoiconic, because Lisp program itself is written as a list, yeah, recursive Lisp. If you want to manage memory yourself, and if you want to have overflows, don't use Go. And if you need a very strong type system, I think that the Rust is better. Yeah, I like Rust, but it's more complicated language, and this is the reason why it won't be
be successful, I think, because in IT, I think that the dumb ideas wins. Usually. And yeah. Yeah, at the end. So thank you.